Alrighty, today we are moving on to part 2 of our lesson with piecewise functions, and we are going to be writing the equations given the graph. Now, there are two forms that are going to be easier for you depending on what your preference is that you can write these equations in. The first one is point slope form, and if you have forgotten what point slope form is, that is y minus y1 equals m times x minus x1, where m is your slope and x1 and y1 are a coordinate pair on your graph. Okay. Another way you can do this is in slope-intercept form, which you might be more familiar with, and that is y equals mx plus b, where again m is your slope and b is your y-intercept. So I'm going to show you how to do both because both are acceptable. Delta Math will accept both of those answers, and I will accept either answer on your test. So off to the races with this first one. I have two portions of my graph. So I am going to have to determine two things for each of those. One, what is the equation of the line there? And two, what is the domain for that portion of my graph? So let's go from left to right here. On the left, I have a horizontal line. So for this one, I don't have to do really any math. I just need to figure out what is that y value, and it is -4. So for that first portion, it's just going to be -4. And now I need to determine over what x values is that taking place. Well, it looks like it's going from -3 off to -infinity, so that would mean that x is less than -3. And that open circle would indicate that I do not underline my inequality there. So that one, first one, easy peasy. Moving on to the second one, this one is not a horizontal line, so I'm going to have to figure out its slope for either way. Either way, if I'm doing point slope or sloped intercept form, I'm going to need to know the slope of my line. So I need 2 points on this line. Well, here's one. It is an open circle, but I can still use it to help find my slope. That is at 3, -1. And another point that I can see clearly here where it passes is at 5, -4. So I can use either of those to determine the slope of my line. So to do that, that is going to be y2 minus y1 over x2 minus x1. So that is going to become -3 over 2 for my slope. Now, for these first ones, I'll do point slope form because that one requires a little bit less work to achieve. So, point slope form. I know the slope, and then you can use either of these points or another point that's on the line. I'm just going to go ahead and use the first one that I found. So, that's going to be y minus -1, which becomes plus y plus 1 equals m. My slope is -3 over 2 times x minus 3. That is the equation of that line, and this is taking place when x is greater than 3. And again, I am not going to underline that inequality because of that open circle. Okay, now if I wanted to do those same graphs but in my slope-intercept form, for my horizontal portion, this is not going to change, okay? For the -4, it's still going to be -4 when x is less than -3. What is going to change is the equation for my second portion. I need to find my y-intercept. That's going to require a little bit more math. So I already have my slope. I know my slope is -3, 2, and I have this point. I'm going to use that x1 and y1 to find b. So I'm going to say my y -1 is equal to my slope -3 over 2 times my x coordinate 3 plus b. So -3 over 2 times 3, that gives me -9 over 2. So if I want b, I'm going to have to add 9 over 2 to both sides. And 9 over 2 plus -1 is going to give me 7 over 2, I'm going to zoom out just so you can see a little bit better, 7 over 2 is equal to b. So that is my y-intercept. So the equation there would be, again, the f of x implies y equals, so that is going to be my slope, negative 3 over 2x plus 7 over 2, and that domain doesn't change. That's when x is greater than 3. Now, the mistake Ms. Chardaway just realized she made up here is, this is our point slope form, but because we're saying f of x equals, what we need to do is get everything moved over to one side. So actually, what you would be typing into Delta Math is you would subtract this 1 here, so that it's just negative 3 over 2 times x minus 3 minus 1 when x is greater than 3. Okay, so this is what would go into your Delta Math. Okay, one more example. This one has 3 parts and none of them are horizontal, so we have to find the equations for all 3 lines and the domains for all 3 portions which this is taking place. So I'm going to simply go from left to right, starting with this one on the left, and I'm going to do point slope first for all of them. So here is 1 point on this graph, negative 2, 1. And I can see another point on the graph here at negative 4, negative 2. So in order to write the equation of that line, I need the slope, and I need a point on the line. So I'm going to do slope first. That would be 1 minus negative 2 over negative 2 minus 4. So that becomes, forgot to do a minus, minus a negative on the bottom. Apologies. Negative 2 minus negative 4. So that becomes 3 over 2. So positive 3 over 2 for my slope. And then when I'm writing the equation of that line, again, regular point slope form, that's going to be y minus, I'm just going to use this first point here, y minus 1 equals 3 over 2 times x. When I have minus and negative, that's going to become plus. But because I need everything on that one side, I'm going to add the 1. So what is actually going to go here is 3 over 2 times x plus 2 plus 1. And this is all values where x is less than negative 2, open circle, so I don't underline my inequality. All right, on to the next one. I need the slope of this line. So here is 1 point at 0, 7, and another point here at negative 2, 5. I'm going to use those 2 points to find my slope. So that is going to be 7 minus 5 over negative 2 minus 0. And I did that backwards on the bottom. I'm so sorry. 0 minus negative 2. And that is going to be 2 over 2, which is 1. So my slope is 1 there. And I'm just going to, again, use that first point. So that is going to be y minus 5 equals 1 times x plus 2. I need y by itself, so I am going to move to the other side. And I get the 1, which we don't have to write there because we can assume it's in front. So x plus 2 plus 5. For all values between, this one has a certain start and stop. When x is between negative 2, that's a closed circle, so it gets underlined, and positive 1, which is an open circle, so it does not get underlined. And that got real crowded in there, so I am going to fix that just a little bit to make it more clear that x is between negative 2 and positive 1. Okay, the last line, I need 2 points. Here is 1 point at 1, 7, and I can see I have another point here at 2, 3. So I'm going to use my slope form, 3 minus 7 over 2 minus 1. It's going to be negative 4 over 1, or just negative 4. So for my point slope form, I'm just going to again use that first point, y minus 7 equals negative 4 times x minus 1. I need to move the 7 over. So negative 4 times x minus 1 plus 7. And that is for all x values greater than or equal to 1. Again, I have a closed circle there, so I am going to underline my inequality. Now, all of these I need to rewrite in slope-intercept form, which means I need the y-intercept for each of these. Now, we could do this the same way we did previously where we solved for b, or what I can simply do is take each of these point slope forms, multiply everything out, and combine like terms. So for my point slope form on the first one, I'm going to distribute that out. I get 3 over 2x plus 3 over 2 times 2 is 3 plus 1. I'm going to have 3 over 2x plus 4. So there's my first equation in slope-intercept form. Again, my domain does not change. For the middle one, I don't have anything to distribute. I just know that I'm going to be combining the 2 and the 5, so that becomes x plus 7. Easy enough. Again, the domain doesn't change. And then for the last one, I am going to have some distribution going on. Negative 4x plus 4 plus 7 gives me a final answer of negative 4x plus 11. But my domain stays the same. And again, that concludes now day 2 of our piecewise functions when we are writing the equations from the graph.